Friends, hello friends, welcome to the JKSS online lessons. In this video, we are just going to go through science paper 2, which was written by the GCE in the year 2024. Our main focus will be just on section B, where we are going to answer question 1 and 2. So this video might mark to a part 1 of the revision. Stay tuned until to the end of this revision. Let us start answering the questions. Right. So section B consists of 45 marks. Answer all questions in this section. Write your answers in the spaces provided in this section paper. Question B1. A box of chemicals in a laboratory has the following symbol attached to it. So we have the box containing of this box of chemicals. It has the symbol attached inside. Now, before we start answering the question, we need to make an observation and conclusion according to the symbol inside the inside the box. So what conclusion and observation that we can make? The observation that we can make is that the symbol in the box represent frames of fire. So the symbol in the box represent frames of fire. From the observation, we can conclude that the fire in the box, it seems to be highly flammable. Now, we have the key term right over here. So the fire inside the box, it seems to be highly flammable. Now, what is highly flammable? Something that is highly flammable, it is something that catches fire easily and burn quickly. For example, like paper, gasoline, and dry wood are flammable. They can start burning if they get too hot or touch a flame. So something that is flammable, it catches fire easily and burn quickly. Let us start answering the question. Question B1A, Roman numeral number 1. Describe the nature of chemicals in the box related to the symbol. So we have already said that the nature in the box related to the symbol, it appears to be highly flammable. Question 1, question A, Roman numeral number 2. In a laboratory, write a laboratory law that is observed when handling chemicals in this box. So the laboratory law, since this chemical, it is highly flammable, we should keep away liquids and any substances that are highly flammable. To keep away liquids or chemicals that are highly flammable with highly flammable. Let us move on to question B1. When a bottle of ammonium is opened, within a few minutes, its smell spreads throughout the laboratory. So ammonia, it is a gas. Whenever we are dealing with the spreading of gas from one location, which is the region of higher concentration, to a region of lower concentration, we are dealing with diffusion. So let us start answering the question. Question B1. Name the process responsible for the even spreading of the smell of ammonium solution. So what is the process called? We have what we call diffusion. The movement of substances from a region of higher concentration to a region of lower concentration. These substances are mainly what? Gases and what? Oh, they are mainly gases. So it occurs mainly on gases and fluids or liquids, in short, such as water. Question B2. Describe the process responsible for the even spreading of the smell of ammonium solution. We have to describe what diffusion is. So, say ammonium has moved from a region of higher concentration to a region of lower concentration. So, in short, this is the definition of diffusion. It is the movement of particles from a region of higher concentration to a region of lower concentration. All right. Question B, Roman number 3. Relate the evidence which the process named in B1 provides to the kinetic theory of matter. Relate the evidence which the process named in B1 provides to the kinetic theory of matter. So the kinetic theory of matter, this is the theory that we use to investigate the constant movement, the random constant movement of particles, especially those especially gases and what? And liquids. All right. So we have two theories that we use in order to investigate the kinetic theory of matter. We have the diffusion theory and the Brownian motion theory. All right. So we have to relate this in terms of diffusion. We can say the particles of ammonia solution have moved at random and constant speed, or they are free to move. That's all. All right. Let us move on to the next question, which is the last one from our revision package. Question B2. The following diagram shows a piece of apparatus used in a laboratory. So we have a piece of apparatus right over here. We have the stopper and the tap. Before I start answering the question, we have to know what this piece of apparatus is. So this piece of apparatus, it is what we call the separating funnel. So what is a separating funnel, and what is the important? How is this separating funnel used in the laboratory? A separating funnel is a glass tool used to separate immiscible liquids. So immiscible liquids that do not mix complete, or that do not mix, they form layers, such as when we combined water and cooking oil, you discover that the layers of cooking oil will be on top and the water will be on the bottom, because they are immiscible. They cannot mix because of their different density. All right. It is used to separate what? Two layers of liquid based on their different densities, like oil and water. So let me bring up the diagram that of this apparatus, clear diagram. We have this diagram right over here. So this is how a separating funnel look like. So on top right over here, we have a stopper. This is stopper. Then we have a separating funnel. The all of this is a separating funnel. Then we have a corrosion oil. So this one is a oil. Then we have water. Have you seen oil on top, water on what? On bottom. Because water is more denser than oil. Then we have a stopper cork, which is what? Also known as a tap. Alright. So apart from this diagram, we can also bring on this diagram. So right over here we have a separating funnel. This separating funnel, we have petrol, water, then we have what? Tap. A tap. So we are separating what? Petrol from what? And from, or we are separating water and petrol. So you discover that the layers of petrol will be on top, while the layer of water will be on bottom. Then this what? This tap will be what? We will be adjusting this tap by closing and opening until all the water poured out from the what? From the separating funnel. This is how the apparatus is what? It is used. Alright. Let us start answering the question. Question 2a. Name the piece of apparatus shown in the diagram. So the piece of apparatus, it is the what? The separating funnel. B. Manual number 1. Identify one property of a mixture separated by the piece of apparatus named in A. So what is the property of the mixture? So we have already said that liquids that do not mix complete, it is the property immiscible what? Liquid. So the properties of a mixture is a miscible liquid or liquids that do not mix completely. Suggest the names of 2 liquids that can be separated by the piece of apparatus shown in the diagram. So the names of the liquid, we have what we call water and cooking oil. The last question. Suggest 2 precautions that need to be taken to separate the mixture in B2. So the precautions, the steps that you before, during, and after an experiment. So these things are called what? Precautions. Precautions are simply steps, methods, procedures that a person needs to follow whenever he or she is conducting what? An experiment in order to avoid mistakes. So what are 2 precautions that we need to follow whenever we are conducting an experiment using this piece of apparatus known as what? The separating funnel. So we have these precautions. Number 1, observe at a good angle. You have to observe between 2 layers. Observing the difference between what? 2 layers. You have to wait until the layers have formed. Alright. So number 2, close the tap before putting the mixture. So we have to close this tap. You have to close this tap before what? Putting the mixture. Because when we left it, let's say for instance we left it open, the mixture will do what? They will all come out, they will all drain out from the what? From the separating funnel. So we have to close this in order to avoid such a mistake. Have you seen? So let the layers fully separated. So we have to let the layers, let's say of water fully drained, liquid remained fully what? Separated, in order to avoid what? Certain mistakes. The last one, open the tap slowly to drain one layer. So you have to open this tap slowly, not fast but slowly, in order to drain the layers. So from this precaution, you can just choose 2 precautions. Make sure that you have a book where you are copying these questions for the sake of revisions. Alright, and don't forget to like this video, share to your friends so that they might also enjoy this same video, comment and subscribe to our channel for more video lessons that are coming. Thank you guys for watching. See you in the next one. Bye bye.